Okay, this is an example problem for Physics 1000, summer 2013. This is a simple circuit consisting of a voltage source and two resistors. And for this, we're going to work the same diagram for a couple of different problems, a couple of different questions. But this one, the question that I'm going to ask is, what is the equivalent resistance of our series of resistors up here, R1 and R2? What is that equivalent resistance? In other words, if I were to take out R1 and R2, which are two resistors, and replace them with one resistor that was not going to change anything else in this circuit, what would that be? I don't want to change the current. I don't want to change the voltage. That's typically set by a battery or something like that. But if I were to replace these two resistors with one resistor and not change anything, what would that resistor, what value of resistance would that have to have? So the way to do this is pretty straightforward. If you remember from class, this is a series circuit. In other words, the current flows through all these components in a series. It doesn't split off anywhere. For a series circuit, the equivalent resistance is simply the sum of the individual resistors. Sum of individual resistors. I'll just abbreviate everything there. So in this case, it's really straightforward. All you do is you add them up. In this case, the equivalent resistance of R1 and R2 is just R1 plus R2. I don't even need to write down the numbers. It's 10 ohms and 15 ohms. I can just put in, that's 25 ohms. No big deal. So if you were some sort of electrical engineer and you would design this circuit to do a particular task, and you took it to your boss and showed it to him, and perhaps he would be like, I really like this circuit, it's going to be awesome. However, we've had some budget cuts. We can't afford to buy two resistors. We can only buy one. Can you replace this with one resistor? You would say, sure, I can do that. I know this is a series circuit. I know that I just add the resistances, so I would just put them together. So instead of putting in two resistors, I'm just going to buy one. That's 25 ohms, and that's going to replace my 10 ohms and 15 ohms, and it won't change anything else in the circuit. It's not going to change the current. It sure is not going to change the voltage. It's just going to change the fact that I have two resistors and now I have one resistor. In this problem, that seems, you might ask yourself, why would you want to do that? But in more complicated problems, that's going to be a very important principle to hang on to. So get it in your mind, hang on to it, and we'll have a few example problems to work about that, or a few homework problems to work about that.